Hi everyone, Mr. Tegmeyer here. Today's topic in this video is technical writing, and we're going to talk about some of the elements and standards. And the reason we're going over this is because it is so important to be an effective communicator as an engineer. And so some of the things we're going to talk about in this video include the following. I'm going to talk about the importance of technical writing, what is technical writing, talk about some reports and different layouts, some substance called front matter, text, and back matter. That will make sense when we get to it. And then finally, we will wrap up with some tips for writing. So what's the big deal about writing anyway? I mean, why is it so important? Why can't you just talk to somebody? Well, the importance of writing is super critical. You can have the best idea in the world as an engineer or as an entrepreneur, but if you can't communicate what that is and what the requirements are, it really isn't worth anything. So to be able to effectively communicate both in writing and orally is critical. So here's an example. So let's say you're a project engineer and you need to communicate something to your boss. Your boss is going to want to know all of the details. You know, why are you asking what you're asking? You're probably going to be making a recommendation of some kind. So what is the background? What are the details? Why are you recommending what you're recommending? He or she, in turn, is going to feed back to you and the staff and customers, you know, why things are, why he makes the decisions or she makes the decisions that they make. And a lot of times, and I've been on both sides as the giver and the receiver, if you don't have the right context, if you don't use the right words, it can cause a lot of problems. So of course, the kind of writing we are talking about is technical writing. So technical writing includes a lot of different things. For example, here you can see proposals, regulations. When a lot of people think of technical writing, they really don't think of manuals. If you've ever gotten a kit, you know, when I was a kid, I used to put together plastic models of airplanes and cars and all kinds of things, and it would come with instructions. So instructions are technical writing. If you've ever bought a piece of equipment, if you've ever gotten a new phone, for example, the manuals that are provided to you are examples of technical writings. But one of the things we're going to focus on, of course, are technical reports. You can see emails and memos. I really don't think of those as technical writing, although certain kinds of memos probably could be. So technical writing, as you can see here, is just kind of writing that's used to convey information, technical information for business purposes or engineering or scientific purposes. And the point of this slide is just to reiterate that it is not used to entertain or create suspense. My personal favorite point on this whole slide is the very last bullet. You know, good technical writing is not to invite different interpretations. Good technical writings will always be interpreted the exact same way, dependent. Doesn't matter who the reader is. So that is a kind of a key point to keep in mind. So technical reports are different than a report that you might do in English class, because as the title implies, a technical report is usually used by engineers or scientists to convey very technical information. And you might write a technical report to your customer or to your boss. And the ANSI, ANSI, American National Standards Institute. Sorry, I'm a little tongue-tied. ANSI provides a lot of guidelines, and we're going to go over those guidelines, but I want you to know before we kind of get started and I show you what it looks like, every company has their own way of doing things. And in fact, I kind of have my own way of doing things that I've developed over the years that works for me. So as we go through the next few slides, we'll go over the ANSI version, and I'll kind of give you what I use and what I like to use and why. Well, one of the things ANSI calls out and differentiates what's a little trivia, really more than anything, is a layout and format. So, and the two are different. A lot of people think that they're kind of the same thing, and in fact, I really kind of do also, but technically they're not. And I do like the example they give here, where they say if you have a newspaper, which almost don't exist anymore, but go to a web page, and if you look for stock market information, it's usually found in a very specific section. And that's called the layout. And the way it is presented is essentially the format. So I think you can see what the differences are there. So in the ANSI format, they have all these different sections of a technical report. Now, I got to be honest and say that I have rarely seen any technical report that has all of these elements, but it is nice to know what they are. You will see certainly some of these and maybe even most of these, depending on what type of document you are writing or reading. And so what we usually focus on in EDD, our class, is really the text, because that's we don't get too technically involved. I don't want you guys becoming authors. I want you working on the engineering design process and hopefully having some fun. So let's go through some of these things. So the front matter is exactly as it implies. It's what goes on the front, towards the front of the report. So you would typically have a report that's bound, and it depends on what type of report and how you decide to bind it. There might be some very specific ways it has to be bound. I know that I put together over the years several reports for proposals, responses to requests for proposals from customers, and they had to be bound certain ways. But it has all the things that you would think. It's got your title, the author's name, publisher, if that's absolutely necessary, a date of publication. So for our purposes, it's your name, the class, my name, perhaps the period and the date. So the title page is really just a duplicate of the cover. So a cover would be really more for a bound piece. So something where you might have a 3-ring binder or something like that. Well, for very long formal reports, you will read something called an abstract. Most of you, I think, are probably familiar with that term and what it is, but just to be clear and what ANSI says, an abstract will have a statement about purpose, scope, and findings. It is important to understand what those are. So the purpose identifies, why you're doing this. Why are you building this new car? Who is your target market? The scope would be what are the limits, what are the boundaries? Are you designing this car to sell in the United States, in Illinois, Naperville? How far does it reach? And then finally the findings, you're going to include, well, what did you find? What are the results? Also, an abstract is very short. I think the longest abstract I've ever seen is probably a page and a half. Mostly they're going to be half a page, maybe a page. And again, you can kind of think of an abstract as a very long introduction. If you are sending something to a CEO of a large company, he's not going to want to read a whole report. He's going to want to read probably an abstract. There aren't any abbreviations, there aren't any tables, figures. It's just the bare bones facts. If you were to pull out everything and you had 30 seconds on an elevator to tell Bill Gates why you want to work for and why you should work for Microsoft, that's the abstract. Well, following the abstract, still within the front matter, you have a table of contents. I don't really have to tell you guys what that is. You guys know. And then following that, when you really get into technical journals, articles, excuse me, you will have a list of figures and tables. And figures and tables are different, but you should be able to see those either in an appendix or typically right after the table of contents. And just so we're clear on what a figure is, it's any drawing, photograph, I call it a graphic, any kind of graphic that's used to help you make a point. So here, for example, you see some sort of fixture. It says figure 8 steam diverter, and a couple of things to note: that it has a number and a title, and that those are below an image. So every time you show a picture or a graph or something like that, it should have a title and it should be below that. And if you do show it, this is one thing that I see sometimes we do in our writing in our class. You know, we show a picture, but we don't really discuss it much. So if you're showing something, make sure you discuss why it's there and why it is significant to your problem. Table, on the other hand, I think everybody knows what a table is, so I don't think I have to explain that. But a table is treated a little bit differently than a figure because while it does have a title, and it should always have a title, and again, you should always discuss what it is and why it's there and why it's significant. It has a title and it says a table and a number up top, not the bottom. So we've gone through all the front matter. The next section is the text. And if we think back to that slide that had the blue, the maroon or the purple, and then the light blue, this is really most of what we are going to use in EDD. And so if you think about an analogy to something you might do in English class, you have on a report in English, you might have an introduction, a body, and a conclusion. You can kind of think of text. This part is really the body. So like front matter, text, the text portion includes several different sections. It's going to have a summary and introduction, and quite honestly, this is where I differ a little bit. I usually put these things together. And then at the end, similarly, I usually put conclusions and recommendations together. So we'll talk a little bit about each of those and what ANSI says and kind of what I say. So according to ANSI, text summary, states the problem, the method, kind of says, hey, this is why we're here. It also doesn't really have this, and this is why I include the summary and introduction together because of the second bullet. It contains no new information that's not contained in the report. So to me, that's really what an introduction is. If you ever take a speech class, a lot of times what they tell you is to break it up into 3 parts. Tell your audience what you're going to tell them, then tell them what you told them. So that's what a summary and introduction is. But according to ANSI, it contains no new information and it doesn't contain any references. So just the facts. So again, according to ANSI, the introduction goes a little bit farther and prepares the reader to read the main report of the body. Or the main body of the report. And to me, there's really no difference. I guess here you can put references and some other things in your introduction. I usually just include them together. So whether you want to use ANSI's version or my version, at the beginning, your summary or your introduction should include these things. So what is the subject? You're going to tell the reader what the topic is, maybe what some of the theory is, a little bit of the background, why it's significant, why you're reading about it, which leads into the purpose. So what is the reason that you're doing what you're doing? And then finally, you're going to talk about, well, what are the limits. I used a car example earlier. You're designing a car that's going to drive on the right-hand side of the road in the United States, and you can kind of take it from there. But you should have at least those three things in your intro. So in the methods, assumptions, and procedures sections, this is where you get into describing, what did you do? Make sure that you include what system of measurement you're using, types of equipment, test methods, and so on. If you are doing some experiment, you might not be doing an experiment, but here at least you're going to tell the reader, what you are doing in good detail, but with few words, as few words as possible. So let's break those things down a little bit farther. So let's talk a little bit about methods. So how did you discover the problem, or why did you decide to work on this problem? Talked a little bit about what measurement system was used. I think one of the really important things for a reader to understand and to be included in any report are the assumptions. So for example, you may recall that throughout the year I've been using my example of the kicking tee. And one of my assumptions when I did my testing was that the air density was that at standard temperature and pressure at sea level. Now, is that accurate? No, it's not completely accurate because I didn't do it at sea level. It wasn't at the right humidity and so on. But that's used at least as a basis or a baseline so other people can understand. If I told them that I was in Champaign, Illinois, and it was a certain altitude and relative humidity and so on, that just adds a lot of complexity. So it's easier just to state what your assumptions are, and very, very important. And then the results and discussion section is exactly as you would think it would be. What are your results? What did you find? And then the discussion part is probably one of the more important things I think in our EDD class that I would like us to work on is let's discuss what that means. Don't just write down what happened. Why is that important? What conclusions can we draw from that, from those results, if anything? And that's a big part of what I think is very important. And the results are like I just mentioned. What did you learn? What happened? What are the results? Did the trend go up or down? Did it break? Did it not break? What happened? Usually you present your results in some sort of table or graph. Engineers love that stuff. And then the discussion talks about the significance. I think that is the biggest thing is, so what? You got these results. Now what? So what? How does it affect your design? Does it affect your design? Should it affect your design? And how? And then what are you going to do about it? And then finally, when everything is said and done, we get to the conclusion. And I'd mentioned before, just like if you take a speech class, you're typically going to tell your audience what you're going to tell them, and then tell them what you told them. And that's really kind of what the conclusion is. It's the tell them what you told them kind of thing. So you're going to restate your results. It's kind of a summary in reverse. So what were your results and what are the implications? What is the big so what? And this is where it's okay to put your opinion. Usually in some type of, in a technical document, you keep your opinion out of it and you want to just speak with the facts. But the conclusion is where you want to put your opinion if it is required. And then finally, near the last part of the text section is a section called recommendations. And this is where I differ somewhat from ANSI. They have these as the conclusions and recommendations as two separate sections. I usually just write a heading called conclusion and recommendations because I almost always have some type of recommendation. And if I don't, I just delete the word. So a recommendation might be, well, for example, in EDD, you definitely at the end should have some type of recommendation. So you're creating a prototype for whatever your project is, and a recommendation would be, what next steps are you going to take? So if you were working in the real world, or if you want to put a patent on your design, truly, what would be your next step? You made a prototype out of wood and plastic. You might want to find a machine shop to make your next one out of metal, and so on and so on. You might want to miniaturize circuits. So what are your recommendations? What are the next steps and why? And this slide really, I just kind of went over, what are additional information that needs to be gone over or learned, and what additional actions can you take? And then finally, the references section, which you all know. Um, Depending on what type of company you work for, depending on what type of professor you have, what class you have, each class, each company is going to have their own standards, not just for a technical report, but also for references. So just make sure that you understand what those guidelines are and follow those. And then finally we get to the back matter. We've been through the front matter, all the table of contents and all that good stuff. The text, which is what we really go over mostly. And then there's the back matter stuff, which we really don't cover in this class. I believe we have in one element used some appendices, but that's really about it. But anyway, let's take a look at that. So Backmatter does include appendices, bibliographies, all these things that you probably have seen in a textbook. I have never written a report so big that I needed all this stuff. Very rarely. I'd probably have for a grad class or two, but in the real world, unless you're in a lab environment in some type of or a super duper huge project, you're not going to need to include all these things. You might want to include some appendices and a glossary. That's maybe about it. I do think this slide is worth talking about. It talks about the appendix, and we did use an appendix in one of our elements, and I could tell that that was a new concept to a lot of us. So the things that go in an appendix are the things that it's necessary information to understand the topic and understand maybe how some conclusions were drawn. But if you put all of that information in the main body, it would just be way too long. So for an example, here you see flow charts, large table of data, math analyses, large illustrations, and so on and so on. Some of those things are you want to be able to have the reader have at their fingertips to know and understand, but it's not something that you would put in the main report because it might take up 20 pages and the rest of your report is 3. So you want to include that. This is where you put it. You put it in the back and you put it in an appendix. And here's just an example and that we've gone over something like this in class. So it has a title, Appendix A, what is included in here, and this is just an example of drawings. You might also have a list of symbols and acronyms and abbreviations. That is fairly common in some very large technical papers that might be peer-reviewed in a journal, something like that. Finally, some tips for writing. So technical writing is, in a lot of ways, should be familiar to you because you've taken writing in English class, and a lot of things are familiar, but there still are some different things. Things that are familiar would be to create an outline. That's kind of like duh. Write the body of the report first, and then the front and the back stuff. I would say uh, fill in what you can when it says write the body first. What I would include, and that's what it means there, is the text, and I kind of agree with that. Have someone proofread. Again, very smart thing to do. Omit personal pronouns. Personal pronouns are our, we, our team. Instead of saying our team or we, think of something else like the project. Our project, it's the project. It's not our design, it's the design. We decided, instead of we decided, it was decided. And then finally, be economical in your writing and eliminate unnecessary words and phrases. This is probably something that, as younger technical writers, you are trained in English class to use all kinds of flowery words and phrases, and really technical writing is just the opposite. You want to write only those words that are required. So, which is really tough to do. It takes a lot of practice. So we covered all these things, the importance of technical writing, what is technical writing, reports, formats, all that kind of good stuff. And that brings us to our conclusion.